Let's have a look at question 40 in this video. So what we have is an Italian restaurant that made a new recipe for the sauce on its pizza. Now a random sample of 8 students were chosen, and each of them ranked on a scale from 1 to 10 the tastes of the original sauce and the new sauce. And we have the data over here, the scores for the 8 students. We also know that the values, the scores basically, are not normally distributed. Then we have the proportion that denotes the population proportion of students that prefer the new sauce, meaning that the difference in scores is the positive one when the new sauce has a higher score than the original sauce. And we're testing with the sign test, whether that proportion is 0.5, so whether we have the same medians in the distributions or not, whether we have a higher tendency, a higher median in the distribution of the new sauce, meaning that the values overall in the distributions are or tend to be higher than the values in the original sauce distribution. Now, how do we compute a sign test? Well, basically, first we have to have a look at the differences. What are the differences between the new sauce and the original sauce? And we only care about the direction of the differences, whether they are positive or negative. So for instance, over here we have 8 minus 6, that's a positive difference. 9 minus 4, that's a positive difference. 4 minus 5, that's a negative difference. 7 minus 8, that's a negative difference. 9 minus 3, that's a positive difference. 9 minus 6, that's a positive difference. 7 minus 7, that's 0. 9 minus 5, that's another positive difference. Now out of this we can see that we have 1, 2, 3, 4, 5 positive differences, 1, 2 negative differences, and 1, 0, so no difference. We call this a tie. Now what we see is that the tendency is to have positive differences, the tendency is to have higher scores for the new sauce. But the question is, how likely is it that this is by chance? Is it a significant difference? Can we say that indeed the new sauce has higher scores, that people prefer the new sauce? Or this is just by chance? So we're gonna test the probability that we have at least 5 positive differences, given that we have a sample size of 7. And why do we use only 7? Because whenever we have a tie in a sign test, we exclude it from the sample. So the tie does not matter to us. We only care about the actual differences. So we take it out of the sample, 1 observation out of 8, we are left with 7 observations. And we also have the fact that we have a proportion of 0.5 under the null hypothesis. So we can calculate this probability by looking again at the binomial distribution, because a sign test, we work it out with the binomial distribution. Now, we will have the probability that x is actually 5, given that we have 7 observations and the proportion is 0.5, and then we'll add the probability that x is 6, given that you have a sample size of 7 and a proportion of 0.5, and we also add the probability that x is 7, given that n is 7, a sample size of 7, and the proportion under the null hypothesis is 0.5. Now if we work out these values by looking them in the table, we can see that the corresponding probabilities are going to be 0.1641 plus 0.0547 plus 0.0078. Now before just working out the math, I'd like to point out a thing. Notice how the probability of having higher positive values by chance is becoming less and less. So the probability of having 6 positive differences from a sample of 7 is just 5%, and the probability of having 7 positive differences out of 7, so the probability that all of them happened by chance is even lower, 0.0078. so that's less than 1%, and the intuition is making sense, because the probability of having only positive differences, so the probability of having this trend that the new sauce is highly preferred over the original sauce, is unlikely. We tend to have on average an equal distribution between the positive and negative differences. That's why the probability, the likelihood of having only positive differences is that low. It's just statistics. It's not very common to see. That's why we'll always have this trend in the binomial distribution, that the probability of having more and more positive differences out of a certain sample is becoming less and less. Now, if we add up all these probabilities, we would end up to 0.5 0.2266, and if we estimate, that's 0.227. And if we have a look at the answer key says that the p-value, the probability that we just calculated of this sign test, is 0.227, and that's what we saw. So the answer is true, and we are done.